Today, we're diving into a new AI model from Meta AI that learns to interact with the real world in a way that's, well, surprisingly human. We're not talking about programming every little move. Nope. This is about teaching a machine to learn just by watching. So our story kicks off not with endless lines of code, but with a robot arm that can actually plan its own moves. This is where all that theory gets put to the test, and honestly, the results are pretty amazing. So check this out. The robot is picking up a cup and moving it. Now, that might look simple, right? But here's the kicker. It was never, ever trained on this exact task. This is what's called zero-shot deployment. It's seeing a puzzle for the very first time and just figuring it out. Which, of course, leads to the big question, doesn't it? If nobody taught it how to do this specific task, how in the world does it know what to do? Well, the answer, the secret ingredient really, is giving the AI something that looks a whole lot like common sense. It's this deep intuition about how the physical world works, letting it predict what's going to happen next. And it builds this intuition not from a rule book, but just from watching. The technical term for this common sense is a world model. The best way to think about it is like an internal physics engine for the AI. It's a mental simulation it runs to guess what will happen if it tries a certain move. It's basically the AI's version of gut instinct. And you know what's wild? This is pretty much how we learn. You and I weren't born understanding physics. We built up our own world models by watching a ball fall or a glass tip over. This AI is doing the exact same thing, but its experience comes from binge-watching millions of hours of video. All right, so how on earth do you build one of these world models? The first part of the training is massive, and it's totally passive. The AI just sits back and observes an incredible amount of video. And when I say a lot of video, I mean a lot. The model, which is called V-JEPA2, was pre-trained on over 1 million hours of public videos from the internet. It saw everything you can imagine: cooking shows, people playing sports, you name it. And all along, it was just absorbing the basic rules of our world. So how does it learn from all this? Imagine the AI is watching this clip of a dog. To start, it gets to see the whole picture, the full context. But then, this is where things get really clever. The researchers basically play a game with it. They hide huge chunks of the video, turning it into a kind of digital jigsaw puzzle. And the AI's job? Figure out what's going on in the pieces it can't see. And here's the brilliant twist. The AI isn't trying to guess the exact color of every single pixel. I mean, that's impossible. Who could guess the exact position of a single blade of grass? Instead, it learns to predict the abstract ideas. It learns that if it sees a dog running to the left, the hidden piece to the left probably contains, the rest of the dog still running. It learns the predictable stuff about the world and learns to ignore all the random, unpredictable noise. Okay, so the AI has built this powerful, common sense brain just by watching videos. But what good is a brain for physical tasks if it doesn't have a body? So the next step is to connect all that knowledge to actual, real-world movement. And this is where the efficiency of this thing will just blow your mind. After learning from 1 million hours of general videos, it only needed about 62 hours of specific footage of a robot arm doing its thing. That massive difference is what makes this whole approach so powerful and practical. Think of this short, hands-on training phase as making the final connection. It's what creates the V-JEPA2 AC model. The AC is for action conditioned. This is the piece of the puzzle that teaches the AI, okay, all that stuff you learned from cat videos, this is how it applies to your robot arm. So with that brain and body now connected, let's circle all the way back to our robot. It's time to see the real payoff from this unique way of learning. This zero-shot ability is the whole ballgame. It's the difference between an AI that just memorizes a task and one that actually understands it. It means the model can generalize what it knows and apply it to totally new situations without needing to be retrained from scratch. And the results? Well, they really speak for themselves. V-JEPA2 can figure out its next move in just 16 seconds. A competing model? It takes 4 minutes. And when it comes to actually moving that cup, it nailed it 80% of the time, which just blows another leading model's 15% success rate out of the water. That's a huge leap in both speed and reliability. So how is it so fast and so accurate? It uses its world model to plan ahead. It literally imagines the future. You give it a picture of the goal, say the cup on the other side of the table.
Then, in its mind's eye, it runs through a bunch of different moves, predicting what would happen with each one. It simply picks the sequence that it thinks will get it closest to that goal image.
So, let's just recap the big wins here. First, this model learns from just watching, not only from doing. That makes it super data efficient for physical stuff. Second, it can generalize to brand new situations without needing to be retrained. And finally, it all comes together to make real-world robot planning fast and effective. And all of this leaves us with a really fascinating question to chew on. If an AI can learn the fundamental physics of robotics just by watching a bunch of internet videos, what's the next complex skill it's going to master simply by watching us?